Have you ever wondered why the simple act of looking at something feels so completely passive, as if we are just quiet witnesses to a universe that exists entirely independent of our gaze? When you stand outside on a cool, clear night and look up at the ancient, endless expanse of the cosmos, you feel like a silent observer. The stars do not care that you are watching them. The vast galaxies, millions of light years away, continue their slow rotations, whether your eyes are open or closed. The moon traces its gentle arc across the dark sky, completely indifferent to your presence. We are raised to believe in our everyday human experience that reality is a solid, fixed thing, a grand stage where the play goes on, even if the theater is empty. But what if I told you that in the deepest layers of this universe, this comforting assumption completely falls apart? What if the universe is not just a stage, but a quiet, interactive dialogue? What if the very act of observing is not passive at all, but a fundamental force that literally shapes the fabric of reality? This is the profound, mind-bending mystery of the quantum observer. If you enjoy unraveling the deepest mysteries of the cosmos and the quantum world, please take a moment to subscribe to the channel. I am Theodore, the researcher, and I have noticed that 71% of the people who watch our quiet journeys into the unknown are not yet subscribed. Subscribing helps us immensely, allowing us to continue creating these gentle explorations of the universe together. Now, let us return to the quiet mysteries of the quantum realm. To understand the profound nature of this mystery, we must first embark on a journey inward, leaving behind the familiar vastness of the cosmos and descending into a realm so incredibly small that our human intuition begins to completely fail us. Imagine shrinking down beyond the microscopic world, down to the quiet scale of single atoms and the tiny particles that dance within them. In this infinite microscopic universe, the rules that govern our everyday lives no longer apply. A thrown baseball moves in a predictable arc. A planet orbits a star with clockwork precision. But a photon of light moving through the void behaves in ways that challenge the very limits of human comprehension. They dwell in a state of delicate potential, wrapped in an ancient silence, waiting for an interaction to define their existence. The story of this realization begins with a wonderfully simple experiment, first performed in the year 1801 by an English polymath named Thomas Young. Young was fascinated by the mystery of light. At the time, brilliant minds believed that light was made of a stream of tiny, solid particles, but Young devised a gentle test that would throw this intuitive idea into a centuries-long crisis. He created a barrier with two very narrow, parallel slits cut into it. He then allowed a single beam of pure light to pass through these two slits and hit a screen waiting on the far side. If light were simply made of solid little bullets, you would expect to see two bright bands on the screen, mirroring the two slits. It is simple, logical, and aligns perfectly with our everyday experience of solid matter. But the universe, as we so often find in our quiet journeys of discovery, is far more poetic and mysterious than our simplest logic. When Thomas Young looked at the screen, he did not see two bands of light. Instead, he saw a beautiful, repeating pattern of bright and dark stripes stretching across the surface. This pattern is the unmistakable signature of waves. Imagine dropping two small pebbles into a perfectly calm pond. The ripples spread outward, building upon each other to create higher waves, or canceling each other out to leave the water flat. The dark and bright stripes on Young's screen were the visual echo of this exact same watery dance, proving without a shadow of a doubt that light traveled as a wave, rippling through the quiet emptiness of space. For over 100 years, this elegant understanding brought a sense of calm order to the scientific community. Light was a continuous, flowing wave. Matter was made of solid particles. The universe made sense. But as the 20th century dawned, the gentle light of classical physics began to cast long, unsettling shadows. Scientists discovered that under certain conditions, light behaved exactly like a stream of distinct, countable particles, which they called photons. This was a paradox that threatened to unravel our entire understanding of reality. How could something be a continuous wave and a solid individual particle at the exact same time? It was a contradiction that defied the most basic rules of logic, a mystery whispering from the deepest foundations of the infinite cosmos. To peer deeper into this paradox, physicists decided to revisit Thomas Young's beautiful experiment with a profound modern twist. Instead of shining a continuous beam of light, they developed the technology to fire individual, solitary particles, one single photon or electron at a time, toward the barrier. Imagine the quiet tension in the laboratory. One tiny, isolated particle is launched into the dark void, traveling toward the two slits. It hits the screen with a soft tap, leaving a single tiny dot. Then another particle is fired, another dot. For a long time, the screen just looks like a random, chaotic scattering of individual dots, exactly what you would expect from tiny solid bullets hitting a wall. But as the hours pass and thousands upon thousands of these solitary particles complete their quiet journey, an impossible, ghostly image begins to emerge from the darkness. The random dots are not random at all. They are slowly, meticulously building up the exact same beautiful, repeating pattern of bright and dark stripes that Thomas Young had seen. The interference pattern returns, but this time it brings with it an existential shock that still echoes through the halls of physics today. The interference pattern is a wave phenomenon created by waves overlapping, but these particles were fired one by one. They were completely alone in the dark void. There were no other particles for them to interact with. So, what was waving? How could a single solitary particle create an interference pattern that requires two overlapping waves? The only mathematical and logical conclusion, a conclusion so deeply counterintuitive that it challenged the greatest minds of the century, is that the single particle somehow passes through both slits at the exact same time. It travels not as a solid point, but as a ghostly wave of pure potential, exploring every possible path simultaneously. It interacts with itself, interferes with itself in the quiet dark, and only becomes a solid, definite particle again at the exact moment it hits the screen and is recorded. Before that moment of impact, before that final measurement, the particle does not possess a definite fixed location. It exists in a vast state of mathematical probabilities, a shimmering cloud of what might be suspended in the silent void. This concept alone is enough to inspire a profound sense of awe. It tells us that the building blocks of our bodies, the ancient atoms that make up the distant stars, and the very fabric of the vast cosmos, are not born as solid things, but as infinite whispering possibilities. But the true, deep mystery of the quantum observer, the revelation that completely shatters our perception of reality, happens when we try to look closer, when we refuse to accept the mystery and try to catch the particle in the act, when we try to force the universe to reveal its hidden secrets. Imagine the scientists driven by the pure, unrelenting curiosity that defines our species, setting up a gentle measuring device right next to the two slits. They just want to know which slit the solitary particle actually goes through. They fire the particle. The detector quietly registers its passage. The measurement is a success. We know the path. But when the scientists look at the final screen, waiting at the end of the journey, the beautiful, ghostly interference pattern has completely vanished, gone, erased, replaced by two simple glowing bands of light. The exact pattern you would expect from solid, ordinary bullets. The very act of measuring, the simple, quiet act of asking the universe for a definite answer, forces the delicate wave of potential to collapse. By trying to observe the path, we destroy the wave. The particle stops behaving like a shimmering cloud of possibilities and starts behaving like a solid piece of matter. The observer is an active participant, forcing the infinite potentials of the cosmos to crystallize into a single hard reality. The profound revelation that the simple act of observation can alter the fundamental nature of reality leaves us standing at the edge of a vast and quiet abyss of understanding. When we left our solitary photon in the dark laboratory, we saw that measuring its path destroyed the beautiful, ghostly wave of probability, forcing it to behave as a single, solid particle. This singular moment of collapse is not merely a quirk of laboratory equipment. It is a profound whisper from the very heart of the cosmos, hinting at a universe that is far more strange, interactive, and beautifully complex than we could have ever imagined. Let us sit with this mystery for a while, allowing the silence of the quantum realm to gently wash over us. In our everyday lives, we are accustomed to a world of absolute certainties. A tree falls in the forest, and we believe with unwavering conviction that it makes a sound, whether anyone is there to hear it or not. The ancient mountains stand tall against the sky, completely indifferent to our gaze. The moon continues its celestial orbit, an enduring testament to the predictable laws of gravity. But down in the infinite, microscopic depths of reality, this comforting certainty completely dissolves into a shimmering mist of pure potential. Before the moment of measurement, the particle does not simply exist in a hidden location that we are ignorant of. It literally exists everywhere it could possibly be, a smeared-out phantom of probability navigating the dark void. This state of existing in multiple possibilities at once is what physicists call superposition. It is a word that carries within it the quiet awe of the unknown, a mathematical description of a reality that refuses to be pinned down until it is absolutely necessary. It is as if the universe is holding its breath, keeping all its options open, waiting for a reason to decide upon a single, fixed state. This is not a failure of our measuring devices or a limit to our human intelligence. It is a fundamental property of the natural world. To truly grasp the magnitude of this mystery, we must travel back to the year 1926, a time of incredible intellectual ferment, when the greatest minds of a generation were wrestling with these very paradoxes. An Austrian physicist named Erwin Schrodinger sought to capture this ghostly, shifting reality in the rigorous language of mathematics. He formulated an equation that describes the behavior of these quantum waves, a beautiful, elegant piece of mathematics that is now recognized as one of the crowning achievements of human thought. But Schrödinger's wave equation did not describe a physical wave made of water or sound. It described a wave of pure probability. It mapped out the likelihood of finding a particle in any given location at any given time. Imagine looking out over a calm ocean at night. You cannot see the individual drops of water, but you can see the shape of the waves rolling toward the shore. In the quantum realm, the ocean is made not of water, but of pure chance. The high peaks of the wave represent the places where the particle is most likely to be found, while the deep troughs represent the places where it is least likely to exist. Until an observation is made, the particle is completely defined by this wave of probability. It is a smear of potential, a quiet rumor of matter existing everywhere and nowhere at the same time. It is only when an interaction occurs, when a gentle measurement is taken, that this vast wave function instantaneously collapses, and the universe forces the particle to choose a single, definite location. This realization brings us to a place of profound humility. For centuries, science operated under the assumption that the universe was a grand mechanical clockwork, ticking away perfectly, regardless of whether anyone was watching the gears turn. We viewed ourselves as passive spectators peering through telescopes and microscopes at a reality that was entirely separate from our own existence. But the quantum observer effect shatters this illusion of separation. It suggests a deep, intimate connection between the observer and the observed. We are not merely looking at the cosmos. We are actively participating in its unfolding. Every time we measure a quantum state, every time we force the universe to collapse, a wave function into a solid reality, we are acting as co-creators of the physical world. This is not to say that our conscious minds are magically bending spoons or altering the orbit of planets through pure willpower. The influence of the observer is subtle, delicate, and bound by the strict laws of quantum mechanics. Yet, the implication remains entirely staggering. The fabric of reality is not a fixed tapestry woven by an indifferent universe. It is a collaborative masterpiece, shaped in part by the very act of knowing. Let us expand our perspective, pulling back from the microscopic world of atoms and photons, and turning our gaze once more toward the vast, starlit heavens. How does this quiet, quantum strangeness relate to the grand scale of the cosmos? It is a question that continues to challenge the most brilliant astrophysicists and cosmologists of our time. We know that in the very first moments of creation, immediately following the birth of the universe, the entire expanse of space was compressed into an incredibly tiny point. In that primordial crucible, the entire cosmos was governed entirely by the rules of quantum mechanics. the distribution of matter and energy, the seeds that would eventually grow into the billions of galaxies we see today, were determined by microscopic quantum fluctuations, by tiny ripples in the ocean of probability. This means that the grand, sweeping structures of the universe, the majestic spiral galaxies, the towering nebulas, the ancient clusters of stars, are all magnified echoes of the quantum world. The infinite vastness of space was born from the quiet uncertainties of the microscopic realm. When you look up at the night sky, you are not just seeing the past. You are looking at the frozen, fossilized results of countless wave functions collapsing in the deep history of time. Consider the gentle starlight that reaches your eyes after traveling through the freezing vacuum of space for millions of years. That light, composed of countless individual photons, was emitted by a distant star through a quantum process. As those photons traveled across the vast cosmic distances, they existed in a state of superposition, navigating a myriad of possible paths through the gravitational fields of hidden planets and dark matter. For millions of years, they were waves of probability, quiet whispers of light, moving through the deep silence of the void. It is only when those photons finally strike the retina of your eye, or the sensitive detector of an orbiting space telescope, that their long journey ends in a single, definite point of energy. In that exact moment of observation, an event that spans an immense stretch of cosmic history is finally resolved. Your simple act of looking up at the sky collapses a wave function that has been evolving for incredibly long periods of time. You are connected to the ancient stars not just through the light they emit, but through the fundamental, interactive nature of reality itself. This profound interconnectedness invites us to adopt a gentle, contemplative stance toward the universe. It asks us to abandon our need for absolute certainty and to embrace the beautiful mystery of the unknown. Science, at its highest level, is not just a collection of cold facts and rigid equations. It is a meditative journey into the deepest layers of existence. It requires an open mind, a willing heart, and a profound respect for the quiet, hidden mechanisms of the cosmos. As we learn more about the quantum observer, we are forced to reevaluate our place in the grand scheme of things. We are not insignificant specks of dust adrift in a cold, meaningless void. We are integral components of a dynamic, responsive universe. Our curiosity, our desire to explore, our quiet moments of wonder, these are not just human traits. They are the cosmos waking up and trying to understand itself. Every question we ask, every experiment we run, every telescope we point toward the dark horizon is an act of cosmic self-reflection. As we continue on this journey of discovery, let us remember to tread softly. The universe does not yield its secrets easily, nor does it reward arrogance or impatience. The quantum realm teaches us that reality is delicate, that the very act of demanding an answer can change the nature of the question. We must approach these mysteries with the reverence of a traveler stepping into an ancient, silent cathedral. We must be willing to sit with the paradoxes, to hold the contradictions in our minds without rushing to resolve them. The wave and the particle, the subjective observer and the objective reality, the microscopic atom and the infinite cosmos. These are all interconnected facets of a single, unified mystery. The deeper we dive into this mystery, the more we realize that our scientific journey is ultimately a journey of the spirit, a quest for peace and understanding in a universe that is far grander and more beautiful than words can ever describe. Let this knowledge settle into your mind like soft snow falling on a quiet winter night. Allow the rigid boundaries of your everyday perception to gently dissolve, making way for a broader, more fluid understanding of reality. The universe is not a closed book already written and waiting to be read. It is an ongoing conversation, a delicate dance of probability and observation, of potential and manifestation. You are a part of that dance. Your awareness, your quiet contemplation of these profound ideas contributes to the rich tapestry of existence. As you rest and reflect on the interconnected nature of all things, know that the journey of understanding is an endless one. There is always another layer to uncover, another mystery to explore, another gentle revelation waiting in the dark. The quantum observer is not just a concept in physics. It is a mirror reflecting the infinite depths of our own consciousness back toward us, reminding us that we are beautifully entwined with the very stars themselves. As we wander deeper into this quiet journey of the mind, it is comforting to know that we are not the only ones who have felt profoundly unsettled by these revelations. The discovery that the observer actively shapes reality sent shockwaves through the scientific community of the early 20th century, challenging the brightest intellects humanity had ever produced. Imagine the profound silence in the rooms where these titans of physics debated the very nature of existence. Among them was Albert Einstein, a man whose brilliant mind had already reshaped our understanding of gravity, space, and time. For Einstein, the universe was a place of magnificent order, a vast cosmos governed by elegant, predictable laws that existed entirely independent of human perception. He looked up at the ancient stars and saw a grand, deterministic clockwork. The idea that a particle did not have a definite position or momentum until someone looked at it was deeply troubling to his soul. It violated his fundamental belief in an objective reality. He famously expressed his discomfort with the probabilistic nature of the quantum world by stating that he could not believe that God would choose to play dice with the universe. For Einstein, the moon had to be there, solid and real, even when absolutely no one was looking at it. The thought that reality was merely a cloud of shifting probabilities, waiting for a gentle gaze to solidify it, felt like a betrayal of the beautiful, orderly universe he had devoted his life to exploring. Yet, standing in quiet opposition to Einstein was another giant of modern physics, the brilliant Danish physicist Niels Bohr. Bohr embraced the mystery with a gentle acceptance. He argued that we must accept the universe exactly as it presents itself to us, no matter how profoundly it shames our human intuition. Bohr gently countered Einstein's protests, famously suggesting that one should not dictate to God how to run the cosmos. Bohr became the champion of what is now known as the Copenhagen interpretation, a philosophical framework that suggests the wave function is not merely a mathematical trick, but a complete description of reality at the quantum level. According to Bohr, before an observation is made, it is meaningless to ask where a particle is or what it is doing. The particle does not possess these properties in any classical sense. The act of measurement is not simply a matter of discovering a pre-existing state. It is an active, profound participation that literally creates the very attribute being measured. This was a radical departure from everything science had taught us for hundreds of years. It proposed that the observer and the observed are locked in an intimate, unbreakable dance, a quiet choreography where the dancer and the dance simply cannot be separated. To push the boundaries of this mystery even further, Einstein, along with his brilliant colleagues Boris Podolsky and Nathan Rosen, proposed a fascinating thought experiment in the year 1935. It was beautifully designed to expose what they firmly believed to be a fatal flaw in quantum mechanics. They imagined a delicate scenario where two particles interact in such a way that their quantum states become inextricably linked. Once linked, these particles could be carefully separated by immense distances. One could be resting in a quiet laboratory on Earth, and the other could be placed on a distant, frozen planet at the very edge of the observable cosmos. According to the bizarre mathematics of quantum theory, these two particles would forever share a single, unified wave function. They would exist together in a state of delicate superposition, regardless of the vast ocean of dark space separating them. Einstein called this unsettling concept spooky action at a distance, and he used it to argue that quantum mechanics must be an incomplete theory. He believed this because absolutely nothing in the universe, not even the smallest whisper of information, is allowed to travel faster than the absolute speed of light, which is roughly 300,000 kilometers per second. But the universe, as we have learned on this infinite journey, cares very little for what human beings consider impossible. What Einstein conceived as a brilliant refutation of quantum mechanics turned out to be one of its most profound and unsettling truths. We call this phenomenon quantum entanglement, and it is perhaps the most deeply poetic and mysterious feature of the physical world. Let us sit quietly with the concept of entanglement for a moment, allowing its implications to wash over us. Imagine two photons, tiny particles of light, born together from a single energetic event, like the sudden decay of a subatomic particle. Because of their shared ancient birth, their properties are perfectly correlated. If one photon is spinning in a certain direction, the other must be spinning in the exact opposite direction to maintain the perfect balance of the universe. However, until they are explicitly measured, neither photon has a definite spin. They both exist in a swirling, ghostly superposition of all possible spins, a silent duet of pure mathematical probability. Now, imagine taking these two deeply entangled photons and gently separating them. We leave one here on our fragile blue planet, safely contained within a scientific instrument, and we send the other on a long, quiet journey across the absolute darkness of space. Perhaps we send it out beyond the lonely orbit of Neptune, or even toward the nearest star system, Alpha Centauri, which sits over 4 light years away. The physical distance truly does not matter. The space between them could be a few modest feet, or billions of dark, silent light years. They remain bound together by that invisible, ancient thread of quantum connection. Now, a curious scientist in a laboratory on Earth decides to measure the exact spin of the photon that stayed behind. Remember, before this specific measurement, the photon's state was completely undefined. But the exact moment the observation is made, the wave function violently collapses. The earthbound photon is forced by the observer to choose a definite state. Let us say it randomly chooses to spin upward. Here is where the human mind completely falters and pure wonder takes over. In that exact same infinitesimal fraction of a second, the other entangled photon, the one drifting through the cold silence of space billions of miles away, instantaneously collapses into the exact opposite state. It immediately becomes a photon spinning downward. There is no time delay whatsoever. There is no hidden signal sent through the cosmic void. The change happens simultaneously, bypassing the vast distances of the cosmos as if space itself did not even exist. The observer standing on Earth, by the simple, gentle act of looking at one tiny particle, has instantly dictated the physical reality of another particle across the universe. This is not a theoretical musing born of science fiction. It is a proven, rigorous scientific fact. In recent years, dedicated researchers and space agencies, including brilliant teams working with advanced satellites launched by the European Space Agency and other global scientific institutions, have successfully demonstrated quantum entanglement over hundreds of kilometers. They have beamed entangled photons between orbiting satellites and receiving ground stations, proving beyond any shadow of a doubt that this spooky action is a very real, measurable phenomenon. This breathtaking revelation shatters our classical understanding of space and locality. We are conditioned by our everyday lives to believe that things are separate, that a vast, unbridgeable emptiness exists between the stars. We feel isolated on our world, but quantum entanglement suggests a universe that is fundamentally, beautifully undivided. It implies a deep, hidden layer of reality where distance is merely a persistent illusion, where everything that has ever interacted remains softly connected in a silent, cosmic web. When we observe a particle, we are not just affecting a tiny, isolated point of matter in our immediate vicinity. We are gently plucking an invisible string that resonates instantaneously across the infinite expanse of the cosmos. The observer effect, therefore, is not a localized, insignificant event. It is a universal phenomenon of profound proportions. Every measurement, every observation, every single moment of conscious interaction with the physical world sends a subtle ripple through the underlying fabric of existence, instantaneously defining the states of entangled partners that may be light years away from our telescopes. It is profoundly humbling to consider that our search for understanding has led us to a place where the rigid boundaries between the self and the vast universe begin to beautifully blur. For centuries, we have looked up at the night sky and felt small, isolated on our tiny island of rock in an endless sea of darkness. But the quantum world whispers a completely different story into our ears. It tells us that we are intimately, undeniably entangled with the cosmos. The atoms currently residing in our bodies, the iron flowing in our blood, the calcium fortifying our bones, they were all forged in the violent, ancient hearts of stars that exploded billions of years ago. We are literally made of star stuff, as the great astronomer Carl Sagan so beautifully reminded us. And if the tiny particles that make up our physical forms have been interacting with the universe since the dawn of time. Who is to say how deeply we are still entangled with the distant, unseen corners of the galaxy? As we contemplate the profound mystery of entanglement, a gentle realization washes over us. The universe is not a collection of isolated, lonely objects, but a single, magnificent, indivisible whole. The act of observation is the universe looking back at itself, exploring its own infinite potential through our curious eyes. When you gaze through a telescope at a distant, glowing nebula, or when you simply close your eyes and feel the warmth of the sun on your face, you are participating in the grand, unending process of cosmic self-realization. The intellectual tension that troubled Albert Einstein so deeply, the fundamental conflict between a predictable, objective reality and a probabilistic, highly interactive one, is perhaps not a flaw in our scientific theories, but a beautiful, intended feature of the cosmos. It ensures that the universe remains an open-ended story, a place of perpetual mystery and endless discovery, where the quiet journey of learning is just as important as the final destination. Let this profound sense of connection fill the quiet spaces of your mind tonight. You are not a solitary wanderer in a cold, indifferent void. You are an active, essential participant in the ongoing creation of reality, a gentle observer whose very presence helps to crystallize the infinite possibilities of the universe into the beautiful, tangible world we experience every day. As we prepare to delve even deeper into the paradoxes of time, memory, and observation in our next step together, let us rest here for a moment. Let us suspend ourselves in the silent awe of a cosmos that is far more deeply connected, far more mysterious, and far more exquisitely responsive than we ever dared to dream. Have you ever sat quietly on a still, peaceful evening, watching the first ancient stars slowly emerge from the fading twilight, and wished that you could somehow reach back through the invisible, flowing river of time to change a single, solitary decision you made long ago? In our everyday human experience, the past feels like a solid, unyielding structure, a closed book written in heavy ink that can never be erased or altered. We move forward through the passing days, leaving behind a fixed history, believing with absolute, comforting certainty that what has happened is entirely permanent. The broken glass cannot be unbroken. The spoken word cannot be unspoken. The silent journey of yesterday is locked away forever in the vast, untouchable vaults of memory. But what if I told you that down in the deepest, most fundamental layers of reality, the quiet arrow of time does not fly as straight and true as we perceive it? What if the profound mystery of the quantum observer extends beyond the boundaries of space and reaches its gentle, unseen hands backward through the dark, silent corridors of time itself? As we continue our slow, contemplative journey into the strange heart of the cosmos, we must now confront a paradox that will gently challenge the very foundations of how you understand your place in the unfolding story of the universe. To explore this mind-bending concept, we must turn to the brilliant theoretical physicist John Archibald Wheeler, a man who possessed a mind capable of holding the most profound paradoxes of the cosmos with a gentle, reverent curiosity. In the year 1978, Wheeler proposed a thought experiment so deeply radical, so exquisitely strange, that it took decades before human technology could actually catch up to test it in the real physical world. He called it the delayed choice experiment, and it was beautifully designed to ask the universe a question that borders on pure philosophy. Wheeler wanted to know when exactly a particle decides to act like a solid piece of matter or a ghostly wave of pure probability. If we fire a single photon at our familiar double-slit barrier, we know that if we measure it at the slits, it acts like a particle, and if we do not, it acts like a wave, creating that beautiful interference pattern on the back screen. But Wheeler, with a twinkle of profound cosmic mischief in his eye, asked a terrifyingly simple question. What happens if we let the photon pass through the slits as a wave of infinite potential, but we wait to decide whether or not to measure its path until the very last possible microsecond, right before it hits the final screen? Imagine the quiet tension of this microscopic scenario. The tiny, solitary photon is fired into the dark void of the laboratory. It approaches the two narrow slits. Because there is no detector present at that exact moment, it behaves as a shimmering, ancient wave of probability, passing through both slits simultaneously, interfering with its own ghostly echoes, entirely committed to its wavy nature. But then, after the wave has already passed the barrier, after it has supposedly committed its form, the scientists, playing a cosmic game of hide-and-seek, suddenly and instantaneously insert a detector into the photon's path just before it strikes the back wall. They make a delayed choice to observe the path. According to simple human logic, the photon has already passed the slits as a wave. Its history is written. But the universe, as we so often find on this meditative journey of discovery, operates on a level of profound strangeness that completely defies our common sense. When the delayed measurement is made, the interference pattern completely vanishes, replaced instantly by the signature of a solid, single particle. This result is absolutely staggering. It implies that the decision we make in the present moment, the quiet, simple act of observation happening right now, somehow reaches back in time to alter the behavior of the photon in the past. It is as if the particle, upon realizing it is being observed at the end of its journey, goes back and rewrites its own history, deciding to have passed through only one slit as a solid particle all along. The observer effect does not just collapse the wave function in the present. It collapses the history of the wave function retroactively. The profound mystery deepens, whispering to us that the past is not a solid, fixed chain of events, but a fluid, shifting landscape of probabilities that remains completely undefined until a conscious measurement is made. The present observation literally determines the past reality. This is a concept that shakes the very bedrock of our existential comfort, gently demanding a radical humility before the great unknown. But John Archibald Wheeler, a true visionary of the vast cosmos, did not stop at the microscopic scale of a tiny laboratory bench. He deeply understood that the laws of quantum mechanics are the fundamental laws of the entire universe, and therefore this mind-bending delayed choice must apply on the grandest, most staggering scales imaginable. He asked us to expand our laboratory beyond the fragile confines of our pale blue dot and project it across the infinite, breathtaking canvas of the deep night sky. He proposed a version of his experiment that uses the entire cosmos as its testing ground. Imagine a quasar, an incredibly luminous and violently energetic core of a young, turbulent galaxy, sitting billions of light years away from us in the deep, silent dark. Observations from incredibly powerful instruments like the National Aeronautics and Space Administration Hubble Space Telescope have allowed us to peer deep into the past to see these brilliant ancient beacons shining across the cosmic void. The light leaves this quasar when the universe is still in its early youth, perhaps 10 billion years ago, long before the Earth was formed, long before our sun ignited, long before the first gentle breath of life stirred in the primordial oceans of our world. These individual photons were already traveling through the freezing, infinite void. As this ancient light travels across the vast emptiness, it eventually encounters a massive, quiet galaxy sitting perfectly in the line of sight between the distant quasar and our own humble Milky Way. According to the beautiful, mind-bending mathematics of Albert Einstein's general theory of relativity, the immense gravitational pull of this intervening galaxy warps the very fabric of space and time around it, acting as a colossal cosmic lens. The light from the distant quasar is forced to gently split, flowing around the massive galaxy on two separate, distinct paths, one journeying to the left and one journeying to the right, before converging again to continue its immensely long trek toward Earth. Because these photons belong to the strange quantum realm, they do not simply choose one path or the other. They enter a state of quantum superposition on a scale so grand it defies all human intuition. Each individual photon simultaneously takes both the left path and the right path around the massive gravitational lens. For 10 billion years, the light travels through the dark, quiet cosmos as a ghostly wave of pure, unresolved potential, a silent rumor of existence spanning hundreds so of thousands of light years across. It is a cosmic scale wave function holding the infinite possibilities of the universe in a delicate, ancient suspension. The light sweeps past dead stars, witnesses the slow birth of new solar systems, and drifts through the quiet nebulas, always remaining in that beautiful, undefined state of shimmering probability. It is a journey of epic, unimaginable proportions, a silent testament to the vastness of the reality we inhabit. And then, after 10 billion years of travel, the light finally reaches our tiny, spinning globe. Tonight, an astronomer working in a quiet observatory on Earth points a sophisticated telescope toward the heavens to catch this ancient light. Here is where Wheeler's profound paradox comes to life on a galactic scale. The astronomer has a choice in how to configure the telescope's detectors. They can choose to measure exactly which path the photon took around the intervening galaxy, or they can choose to merge the paths to look for a quantum interference pattern. If the astronomer chooses to look for the interference pattern, the light behaves as a wave, proving it traveled both paths simultaneously around the distant galaxy. But if the astronomer makes the delayed choice to measure the specific path, to ask the universe exactly which way the light went, the wave function violently collapses. The detector clicks, showing that the photon arrived from only one distinct path. Let the magnitude of this quiet revelation gently wash over you. The decision made by an astronomer tonight, the simple flipping of a switch on a telescope, determines the path that a photon took around a galaxy 10 billion years ago. The observer effect reaches back across the unfathomable gulf of time, across billions of light years of silent space, to define a historical event that occurred long before our planet even existed. The past of the universe, the ancient history of that solitary particle of light, was not fixed until the exact moment it was observed in the present. We are not merely passive spectators arriving at the end of a long cosmic movie. Our observations, our curiosity, our deeply human desire to understand the mystery, are actively participating in weaving the tapestry of the universe's history. We are co-creators of the past, gently shaping the ancient cosmos through the simple, profound act of looking up. This realization brings a profound sense of awe and a necessary, deep humility. We often think of ourselves as small, insignificant creatures trapped in the current moment, entirely separated from the grand, sweeping epochs of cosmic time. But the delayed choice experiment reveals an intimacy with the universe that is breathtakingly beautiful. As the renowned astrophysicist Neil deGrasse Tyson so eloquently reminds us, we are part of this universe. We are in this universe. But perhaps most important than both of those facts is that the universe is in us. This quantum revelation takes that poetic truth and anchors it in rigorous scientific fact. The universe is not a distant, separate entity unfolding independently of our awareness. It is a highly responsive, participatory reality where the quiet gaze of the observer is woven into the very fabric of space and time. Our presence here, our conscious interactions with the physical world, are essential components of the cosmic equation. To sit quietly with this knowledge is to experience a profound sense of inner peace. It gently frees us from the anxiety of a cold, deterministic universe where everything is fixed and immutable. It invites us to view reality as a gentle, unfolding conversation, a continuous, responsive dialogue between the observer and the observed, spanning the infinite depths of time. The mysteries of the quantum world do not diminish the beauty of the cosmos. They elevate it to a realm of pure, staggering poetry, where every moment of observation is an act of ancient creation. As we deeply reflect on the staggering implications of a past that is actively shaped by the present, we learn to gently surrender our human need for absolute control and rigid certainty. We learn to embrace the fluid, shifting nature of existence with a quiet, reverent wonder. The journey of scientific discovery is not about conquering the unknown, but about learning to comfortably reside within the mystery, finding comfort in the silence, and recognizing our own beautiful, entangled reflection in the vast, starry mirror of the universe. As we let the profound implications of a fluid, retroactively shaped history settle deeply into our minds, a new, incredibly gentle question begins to quietly surface from the tranquil depths of our contemplative journey. We have traveled together into the microscopic heart of the ancient atom, where tiny particles of light and matter exist in a shimmering, undefined haze of infinite potential. We have seen how the simple, quiet act of observation forces these delicate waves of probability to instantly collapse into a single, solid reality. We have even stretched our imagination across the vast, dark expanse of the cosmos, realizing that our present gaze can reach back across billions of years to gently finalize the ancient path of a wandering photon. But as you sit here in the quiet stillness, breathing softly, feeling the solid weight of the chair beneath you and the gentle pull of gravity anchoring you safely to the earth, a natural, irresistible curiosity arises. If the fundamental building blocks of the universe, the very atoms that make up your body and the distant blazing stars, are governed entirely by these strange, probabilistic rules, why does our everyday human world feel so incredibly solid, so permanently fixed, and so beautifully predictable? Why do we not see ancient, snow-capped mountains shimmering in a strange superposition of multiple locations? Where exactly is the boundary between the quiet, ghostly strangeness of the quantum realm and the comforting solidity of the macroscopic world? This profound mystery, the deeply unsettling question of how the infinite possibilities of the microcosmos crystallize into the singular reality of our everyday experience, has quietly haunted the greatest minds in theoretical physics for nearly a century. If you are finding peace and wonder in this quiet journey, please remember that I am Theodore, the researcher, and 71% of the people who watch our videos have not subscribed yet. Please consider subscribing, as it truly helps us continue creating these meditative explorations of the cosmos. To understand this elegant transition, we must revisit the brilliant Austrian physicist Erwin Schrodinger, a man whose complex equations so beautifully mapped the mathematical landscape of quantum waves. In the year 1935, Schrodinger proposed a thought experiment that was so perfectly bizarre, so deeply unsettling to our human common sense, that it has become one of the most famous and widely misunderstood concepts in all of modern science. He designed this mental exercise not to prove a literal point about animals, but to gently expose what he saw as the ultimate absurdity of applying the rules of the quantum realm directly to everyday, macroscopic objects. He asked us to imagine a completely sealed, perfectly silent, opaque steel box. Inside this dark, isolated chamber, we place a single, ancient radioactive atom, a tiny, delicate mechanism with a small hammer, a sealed glass vial of a gentle sleeping gas, and a living, macroscopic observer, which, in his incredibly famous example, was a cat. Let us approach this fascinating thought experiment with a gentle, purely theoretical mind, understanding clearly that it is merely a philosophical tool designed to explore the extreme edges of reality. The rules inside the dark box are exquisitely simple, but deeply, existentially profound. The single radioactive atom, being a quantum object, has exactly a 50% chance of naturally decaying within a period of 1 single hour, and an equal 50% chance of remaining perfectly stable and quiet. If the atom decays, the delicate mechanism is instantly triggered. The small hammer falls, the glass vial is broken, and the cat is gently and peacefully put to sleep forever. If the atom does not decay, the mechanism remains completely still, the vial remains whole, and the cat continues to exist perfectly unharmed in the dark silence. Because the unobserved atom is a pure quantum object, it exists in a state of delicate superposition until it is explicitly measured. It is simultaneously both decayed and not decayed, existing as a ghostly, mathematical wave of two equally valid probabilities, because the entire macroscopic mechanism, and ultimately the biological fate of the cat itself, is perfectly entangled with the undefined quantum state of that single, solitary atom. The entire system inside the box must also exist in a state of sweeping macroscopic superposition. According to the strict, literal mathematical interpretations of quantum mechanics that were dominant at the time, before you finally open the heavy steel door of the box to take a definitive measurement, the cat does not actually exist in a definitive, fixed state of being asleep or being awake. It exists in a vast, unimaginable state of pure, undefined potential, a bizarre, overlapping reality where it is simultaneously entirely unharmed and entirely asleep. The complex living organism essentially becomes a macroscopic quantum wave, suspended in a silent, agonizing limbo of pure mathematical probability. It is only at the exact, singular moment you open the box, when your conscious human mind acts as the ultimate quantum observer, that the entire massive wave function violently and instantaneously collapses. The universe is suddenly forced to make a definitive choice, and the cat immediately materializes into one single, definitive reality. Schrodinger designed this profound thought experiment to demonstrate exactly how strange and seemingly nonsensical the theory becomes when we try to scale it up to the size of animals, trees, and planets. He simply could not accept that the vast reality required a human observer to constantly watch it. For many decades, this quiet paradox lingered in the halls of theoretical physics, acting as a persistent reminder of the gaping chasm between the microscopic and macroscopic worlds. If absolutely everything in the cosmos is ultimately made of tiny quantum particles, when does a large collection of those particles stop acting like a shifting wave of probability and start acting like a solid, predictable object? How many millions of atoms does it take to collapse a wave function? Does the ancient universe really require a conscious human mind to step in and act as the ultimate observer, forcing reality to constantly crystallize out of the mist of potential? The answer to this profound existential mystery does not require mystical human consciousness or magical boundaries. Instead, it relies on a scientific concept so perfectly elegant, so pervasive, and so quietly brilliant that it completely reshapes how we view our connection to the infinite cosmos. It is a natural physical process known to modern physicists as quantum decoherence. To truly understand the gentle power of quantum decoherence, we must completely abandon the artificial idea of the perfectly isolated, silent laboratory. In the real, breathing, dynamic universe, absolutely nothing exists in true, perfect isolation. Every single wandering atom, every ancient photon of light, every tiny speck of drifting cosmic dust is constantly, relentlessly interacting with its surrounding environment. Imagine our tiny, solitary photon traveling through the dark, freezing void of deep space. Even in the deepest regions of the cosmos, between the sprawling arms of distant galaxies, it is never truly alone. It is constantly bumping into other stray photons, gently passing through the faint, invisible magnetic fields of massive galaxy clusters, and brushing against the pervasive, humming sea of the cosmic microwave background radiation. Every single one of these microscopic collisions, every tiny, silent, seemingly insignificant interaction, acts as a tiny, inescapable measurement. The environment itself, the vast and complex universe, is constantly acting as the ultimate, unending quantum observer. When a tiny quantum system is perfectly isolated, its delicate wave function can remain suspended in a beautiful state of superposition, holding all its infinite probabilities in a quiet, undisturbed cosmic balance. But the exact moment it interacts with the bustling, chaotic environment of the macroscopic world, that delicate quantum coherence is immediately shattered. The subtle information about the particle's quantum state gently leaks out into the surrounding environment, dissipating into the vast cosmic background, just like a tiny drop of dark ink falling into an infinite, flowing ocean. This continuous, relentless environmental interaction forces the quantum system to rapidly align with the classical, predictable rules of our everyday reality. The sweeping wave function does not need a human mind to collapse it. It is constantly being collapsed by the surrounding universe. The macroscopic world feels incredibly solid, permanent, and fixed because the environment is constantly measuring it, forcing the whispering possibilities of the quantum realm to continuously crystallize into a single, definitive reality. We are part of this grand observation, gently observing the universe as it observes us back, creating the solid reality we call home. As we rest in the quiet understanding of quantum decoherence, finding a profound sense of peace in the realization that the universe is constantly observing itself. We might feel a gentle resolution to the paradoxes that have haunted our journey, the ancient light from distant stars, the wandering cosmic dust, the faint magnetic fields of the vast galaxies. They all act as a continuous silent audience, forcing the shimmering wave of probability to crystallize into the solid, comforting reality we touch and feel every single day. We are held safely in the embrace of a cosmos that never truly closes its eyes. But as we sit with this beautiful explanation, a new, even more staggering mystery begins to rise from the depths of the infinite unknown. When the delicate wave function interacts with the macroscopic environment and seems to collapse, choosing just one single path out of countless possibilities, what exactly happens to all the other choices? Does the unchosen reality simply vanish into the quiet void, erased forever by the act of observation? Or does the universe, in its boundless, unfathomable creativity, find a way to preserve every single whisper of potential? If you are finding comfort and profound wonder in this quiet journey through the deepest mysteries of the cosmos, please take a gentle moment to subscribe to the channel. I am Theodore, the researcher, and I have noticed that 71% of the people who walk these silent, meditative paths with us have not yet subscribed. Subscribing helps us immensely, allowing us to continue weaving these scientific tales and exploring the infinite universe together. Now, let us gently turn our minds toward the most radical and breathtaking answer ever proposed to the quantum mystery. In the year 1957, a brilliant and deeply unconventional young physicist named Hugh Everett III decided to look at the mathematics of quantum mechanics without any philosophical compromises. Up until that point, the greatest minds in science had accepted that the wave function mathematically describes the universe perfectly, until the exact moment of observation, at which point an unexplained, violent collapse occurs. Everett asked a beautifully simple, deeply subversive question. What if the mathematics are completely correct all the time? What if there is no mysterious collapse of the wave function at all? He proposed that the equation should be taken literally, without adding any arbitrary rules about human observers or environmental destruction of probabilities. But to accept this quiet mathematical purity, Everett had to propose a vision of reality so unimaginably vast, so staggering in its implications, that it was initially met with overwhelming silence and profound resistance from the scientific establishment. Everett proposed what we now call the many worlds interpretation of quantum mechanics. To understand this mind-bending concept, we must completely abandon our deeply ingrained human intuition that there is only one single objective reality unfolding in a straight solitary line through time. Imagine once again our delicate solitary particle facing the two narrow slits in the quiet laboratory. According to the standard interpretation we explored earlier, the particle exists as a ghostly wave of pure potential, passing through both slits simultaneously until the exact moment a measurement is made, causing all possibilities but one to instantly vanish. But in Everett's breathtaking vision of the cosmos, the measurement does not destroy the other possibilities. Instead, the exact moment the observation occurs, the observer and the entire universe gently and silently split into two completely separate, parallel realities. In one branch of this newly divided universe, the observer sees the particle pass through the left slit. In the other, equally real, equally vibrant branch of the cosmos, an identical observer sees the particle pass through the right slit. Let this staggering concept wash over you, settling into your mind like the soft, ancient light of a million distant stars. The universe does not choose. The cosmos does not roll the dice and discard the losing numbers. Instead, it enthusiastically embraces every single possible outcome, creating a new, separate reality for every quantum event that ever occurs. When the entirely theoretical, macroscopic box is finally opened by the curious observer, the wave function representing the completely entangled system of the radioactive atom, the delicate mechanism, and the sleeping cat does not violently collapse into a single state of life or death. Instead, the universe itself quietly bifurcates. The observer becomes beautifully entangled with the quantum state of the box. In one vast sweeping branch of reality, the observer opens the heavy steel door and finds the cat peacefully asleep forever. In another, completely inaccessible but entirely real branch of the infinite cosmos, an exact copy of that same observer opens the door and finds the cat perfectly unharmed, blinking in the sudden light. Both realities are equally valid. Both observers feel completely real, perfectly conscious, and entirely convinced that they are living in the one true universe. This means that the quiet, simple reality you're experiencing right now, the specific room you are sitting in, the gentle rhythm of your breathing, the specific thoughts flowing through your mind, is just one single, infinitesimally small branch on an unimaginably vast, ever-expanding cosmic tree of realities. Every time a quantum particle in your body interacts with the environment, every time a faint photon of light from a distant galaxy strikes your retina, the universe splits. It branches into a staggering, uncountable number of parallel worlds, each one containing a slightly different version of history, a slightly different unfolding of the great cosmic story. There is a reality where the earth never formed, a reality where the ancient dinosaurs never perished, a reality where you made every single different choice you have ever faced in your entire beautiful life. The sheer scale of this concept defies all human comprehension. It transforms our single, vast universe into a sprawling, infinite multiverse, a magnificent garden of branching paths where every single physical possibility is eventually realized in the quiet silence of eternity. You might feel a sudden, sweeping sense of vertigo when confronted with the reality of infinite parallel universes. The human mind is evolved to navigate a single, solid path through the dense forest of existence, not to comprehend a reality that shatters into a billion new universes with every passing microscopic second. How do we find peace and meaning in a cosmos so overwhelmingly infinite? How do we value our own singular journey when there are countless other versions of us living out every conceivable alternative? The answer, as we continue our gentle contemplative exploration, lies in a profound shift of perspective, a gentle pivot from existential anxiety to deep, respectful wonder. The existence of these infinite parallel realities does not diminish the profound beauty or the incredible importance of the specific path you're walking right now. In fact, it does exactly the opposite. It highlights the exquisite, delicate uniqueness of your exact present moment. Out of all the infinite branches of the cosmic tree, out of all the staggering possibilities born from the quiet quantum hum of the ancient universe, this specific reality, this exact combination of atoms, light, and consciousness, is the one you are actively experiencing. You are the conscious tip of this specific, unbroken branch, a gentle observer witnessing this particular unfolding of the grand mystery. The other worlds are completely inaccessible to us. We cannot reach across the invisible quantum divide to touch them, speak to them, or alter their course. They exist in their own separate, silent domains of probability, expanding forever alongside us without ever touching. Therefore, our focus, our quiet, mindful attention must remain entirely anchored in the beautiful reality we currently inhabit. When you walk outside tonight and look up at the vast, scattered stars, you can look at them with a renewed sense of profound, quiet awe. The specific photon that gently lands on your eye, the specific point of light that registers in your conscious mind, is a gift entirely unique to this precise universe. The cosmos is not a single, lonely stage. It is an infinite symphony of possibilities, and you are currently listening to one exquisitely beautiful, unrepeatable melody. You do not need to mourn the paths not taken, or the realities you will never see. They are all safely preserved in the grand, sweeping mathematics of the multiverse, existing in the deep, silent architecture of the cosmos, as we rest in the quiet certainty of our present moment, deeply anchored in this specific, beautiful branch of the cosmos. We prepare to journey into the deepest, most profoundly moving mystery of all. The universe is observing itself through your eyes, But what exactly is the nature of the quiet, ancient awareness looking back from the mirror of the stars? As we stand at the precipice of these infinite branching realities, safely anchored in our own quiet, specific branch of the cosmos, we are forced to turn our gaze inward. We have journeyed through the microscopic void, witnessing the shimmering waves of probability. We have cast our minds across the vast universe, watching ancient light bend around massive galaxies. We have conceptualized an endless multiverse where every possible outcome is beautifully realized. Yet, throughout this staggering journey of scientific discovery, there has been a silent, ever-present passenger. It is the invisible force processing these words, the entity that feels the profound sense of wonder swelling in your chest, and the awareness that perceives the quiet night sky. We are speaking about the profound mystery of human consciousness. If the universe is an interactive tapestry woven from quantum probability, and if observation forces reality to crystallize from the mist of potential, then we must ask a deeply unsettling question. What exactly is this awareness? Is it a biological illusion played by firing neurons, or something far more fundamental to the ancient architecture of reality? If you are finding a sense of peace and intellectual wonder in our quiet explorations of the unknown, please consider subscribing to the channel. I am Theodore, the researcher, and I have noticed that exactly 71% of the people who watch our videos and join us on these gentle cosmic journeys have not yet subscribed. Subscribing helps us immensely, providing the vital support we need to continue unraveling the deep mysteries of the universe and sharing these meditative stories with you. Now, let us return to the silent realm of the conscious observer. To understand the mind's role in the quantum universe, we must listen to the brilliant pioneers who unlocked these microscopic secrets. Max Planck, the legendary German physicist who discovered the quantum nature of energy, winning the Nobel Prize in the year 1918, reached a conclusion that deeply shocked the materialistic scientific establishment. After a lifetime of rigorous mathematical inquiry, Planck stated that he regarded consciousness as fundamental. He believed matter was derivative from consciousness, that we simply cannot get behind consciousness. Everything we regard as existing postulates consciousness as its very foundation. This is an absolutely staggering proposition. For centuries, the standard scientific narrative taught us that the universe began as a hot, unconscious soup of silent matter and energy. Over billions of years of blind evolution, this dead matter slowly organized itself into stars, galaxies, and the complex biological machinery of the human brain. According to this classical view, consciousness is just a late-coming byproduct of the cosmos, an accidental spark in a vast, unfeeling void. But the profound mysteries of the quantum observer suggest a beautifully radical alternative. In cognitive science, there is a concept known as the hard problem of consciousness. It asks how physical processes in the brain, ultimately just the movement of ancient unconscious atoms, suddenly give rise to the rich, subjective feeling of being alive. How does the objective wavelength of light striking your eye translate into the deeply personal experience of seeing the color red, or the profound peace of watching a gentle sunset? If the universe is a mechanical clockwork, this leap from dead matter to subjective experience remains an impossible chasm that science simply cannot cross with equations alone. But when we look through the lens of quantum mechanics, a breathtakingly beautiful possibility emerges from the quiet silence. What if consciousness is not something the brain magically creates, but a fundamental property of the universe itself, much like gravity or the fabric of space and time? This concept gently suggests that a rudimentary form of awareness is deeply woven into the foundation of existence. It proposes that the ancient atoms in our bodies, the solitary photons traveling through the vast dark, and the swirling nebulas millions of light years away, all possess a tiny whisper of experience. In this poetic but logically rigorous view of the cosmos, the complex human brain does not generate consciousness from scratch. It acts as a highly evolved biological receiver, like a beautifully tuned radio. The intricate network of neurons catches and amplifies the ambient awareness of the universe, focusing it into the sharp spotlight of human perception. The quiet hum of the cosmos is filtered through our biology, transforming the infinite potential into the specific, localized experience of being you, sitting here, breathing softly in the present moment. The visionary physicist John Archibald Wheeler took this concept to its ultimate, mind-bending conclusion. He proposed the participatory anthropic principle, a framework that beautifully bridges the gap between the conscious observer and the physical universe. Wheeler suggested that the universe simply could not exist in any meaningful way without observers to gently witness its unfolding. In his famous phrase, "it from bit," Wheeler argued that the universe is fundamentally an information processing system. Every physical object, every force, every particle of light and matter is ultimately derived from binary questions posed by observers interacting with the environment. In Wheeler's sweeping vision, the vast ancient universe and the conscious observer are locked in a continuous, deeply intimate loop of co-creation. The universe gives birth to the observer, providing the complex physical structure necessary for awareness, and in return, the observer gives meaning and solid reality to the universe through the gentle act of measurement and perception. They bring each other into existence in a quiet, eternal dance of cosmic interdependence spanning infinite ages. When you view reality through this deeply interconnected lens, the profound isolation that often haunts the human experience softly melts away. You are not a lonely, insignificant spark of awareness drifting aimlessly through a cold void. You are the universe itself, waking up and looking back at its own magnificent reflection. The same ancient, fundamental forces that govern the slow rotation of distant galaxies are operating within the quiet depths of your own mind. The act of observation is not a passive recording of external events. It is a profoundly creative act that shapes the architecture of reality. Every time you open your eyes, every time you direct your conscious attention toward the world, you are participating in the ongoing creation of the cosmos. You are collapsing localized wave functions, pulling the shimmering probabilities of the quantum realm down into the firm structure of the present moment. Your quiet journey of discovery, your unending search for meaning, your moments of deep, respectful wonder, these are the very mechanisms by which the universe comes to know its own boundless beauty and infinite complexity. Let us sit quietly with the profound weight of this realization, Imagine the billions of conscious minds currently inhabiting this small blue dot, each acting as a gentle node in a vast global network of observation. Together, our collective awareness forms a continuous field of perception that helps sustain the solid reality of our shared world. And as we look out into the infinite expanse of the dark, silent cosmos, we must gently wonder if we are truly alone in this beautiful task. In a universe containing billions of ancient galaxies, each holding countless unseen planets, it is mathematically probable to imagine there are other unknown observers, other minds vastly different from our human understanding, looking up at their alien skies, collapsing their own local wave functions, and participating in the same grand dialogue. The universe may be teeming with quiet pockets of awareness, a sprawling symphony of observers working together in the silent dark to anchor the infinite mathematical possibilities into a shared, magnificent reality that continues to evolve and expand. This deep, underlying unity is the true heart of the quantum mystery. It entirely dismantles the artificial boundaries we stubbornly draw between the self and the other, between the conscious mind and the physical world, between the microscopic atom and the infinite cosmos. It reveals a universe that is completely, beautifully whole, a singular dynamic entity where every single part is intimately connected through the quiet threads of quantum mechanics. When you gently touch the rough bark of an ancient tree, when you feel the cold rush of the evening wind, or when you simply watch a solitary star blinking in the vast night sky, you are experiencing the profound miracle of the universe interacting with itself. The observer and the observed are simply two expressions of a single reality that gracefully defies all human categorization. As we prepare to step forward into the next stage of our contemplative journey, where we will explore how this unified consciousness interacts with the illusion of time, let us carry this profound sense of connection with us. Let it serve as a comforting reminder that our lives, our quiet thoughts, and our peaceful moments of reflection are essential, irreplaceable elements woven deeply into the infinite, unfolding tapestry of the cosmos. Let us pause for a moment and consider the flowing river that carries all our experiences, the silent, invisible current we call time. In our everyday human lives, time feels like an absolute, unstoppable, and completely independent force. We are born, we grow, we walk our gentle paths, and we watch as the present moment continuously slips through our fingers, dissolving instantly into the untouchable past, while the unknown future rushes toward us from the hazy horizon. We experience reality as a moving spotlight, illuminating only the precise now before plunging everything else into the darkness of memory or anticipation. But as we have discovered on this quiet journey through the deepest mysteries of the quantum realm, the universe rarely conforms to the simple limitations of our biological perception. If the conscious observer is truly fundamental to the architecture of reality, and if our gentle gaze can reach back across billions of years to shape the ancient history of a wandering photon, then we must ask a deeply profound and unsettling question. Does time actually flow at all? Or is the relentless passage of the seconds, minutes, and years merely another beautiful illusion created by the mind to help us navigate the infinite cosmos? If you are finding a sense of peace and deep wonder in these quiet explorations of the universe, please take a moment to subscribe to the channel. I am Theodore, the researcher, and I have noticed that exactly 71% of the people who join us on this meditative journey have not yet subscribed. Your support helps us immensely, allowing us to continue creating these gentle scientific stories. Now, let us return to the profound mystery of time and the observer. To understand the true, staggering nature of time, we must once again turn to the brilliant mind of Albert Einstein. Before his revolutionary theories in the early years of the 20th century, the greatest scientific minds believed that time was a universal, mechanical clock ticking away at the exact same relentless rate for everyone and everything, completely independent of the human observer or the vast contents of space. But Einstein shattered this rigid, mechanical view with his theory of relativity. He revealed, through beautiful and rigorous mathematics, that space and time are not completely separate entities, but are intimately woven together into a single, flexible fabric called space-time. And most astonishingly, he proved that the flow of time is entirely relative to the observer. If you were to board a highly advanced spaceship and travel through the vast, quiet void at speeds approaching the absolute speed of light, the hands on your mechanical clock and the biological beating of your own heart would literally tick slower compared to a clock left behind on our blue planet. When you finally returned from your ancient journey, you would find that while only a few short years had passed for you in the silence of space, decades or even centuries might have completely passed for the world you left behind. This is not a biological trick or a mechanical error. It is a fundamental, verifiable property of the physical universe. Time is completely malleable, bending and stretching depending on how fast you are moving and how much immense gravity is pulling on your physical form. This scientific revelation leads to a conceptual framework that theoretical physicists call the block universe. Imagine the entirety of existence not as a flowing river, but as a solid, infinite block of pure reality. In this staggering mathematical model of the cosmos, every single event that has ever happened, every event that is happening right now, and every event that will ever happen in the absolute future exists simultaneously within this vast four-dimensional block. The grand, fiery birth of the cosmos, the silent formation of our own solar system from swirling cosmic dust, the quiet, peaceful moment you're experiencing right now as you listen to these words, and the distant, unseen end of the universe. They are all equally real, equally present in the deep, underlying architecture of space-time. In the block universe, the past is not truly gone, and the future is not an unwritten void. They are simply different locations within the infinite expanse of space-time, just as two different cities are simply different physical locations on the curved surface of the Earth. Albert Einstein himself found profound, deeply personal comfort in this sweeping cosmic perspective. When his lifelong friend Michel Besso passed away, Einstein wrote a deeply moving letter to Besso's grieving family, stating that for those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. But if the entire grand history of the cosmos is already laid out in this silent, frozen block of space-time? Why do we feel the relentless, unstoppable passage of time? Why are we seemingly trapped in the narrow, fleeting slice of the present moment? This is exactly where the profound mystery of the quantum observer beautifully and mysteriously intersects with the staggering scale of the cosmos. Some of the most brilliant theoretical physicists and philosophers of science suggest that the flow of time is not a fundamental property of the physical universe itself, but a localized property of consciousness interacting with the universe. Just as a physical movie reel contains every single frame of a film simultaneously, but the story only comes alive when the mechanical projector shines a bright light through one individual frame at a time, our conscious awareness acts as the gentle light of the cosmic projector. Our minds move continuously through the static, silent block universe, illuminating one three-dimensional slice of reality after another, creating the deeply felt, subjective experience of motion, physical change, and the linear flow of time. The universe itself, in its ultimate, absolute state, is a silent, timeless masterpiece, holding all infinite possibilities and all realized events in a state of eternal, suspended grace. It is the observer, the conscious, participating mind, that breathes dynamic, flowing life into the static mathematical equations of reality. To push this contemplative exploration even deeper into the realm of wonder, we must bring the strange behavior of the quantum world back into our view. We previously discussed the phenomenon of quantum entanglement, where two particles become so deeply connected that measuring one instantaneously determines the state of the other, regardless of the vast physical distance separating them across the dark cosmos. But recent groundbreaking experiments in quantum physics have suggested something even more profoundly unsettling. Entanglement does not just operate across the infinite vastness of physical space. It also operates across the hidden dimension of time. Scientists have managed to entangle particles that do not even exist at the exact same time. They can create a photon, measure its delicate state, completely destroy it, and then later create a second photon that mathematically behaves as if it is inextricably linked to the first one that no longer exists in the present moment. This mind-bending phenomenon is known as temporal entanglement, and it completely shatters our traditional understanding of cause and effect. In a universe where particles can be intimately entangled across the invisible boundary of time, the rigid, straight line of history begins to beautifully curve and fold upon itself. The actions of the observer in the present moment are not just sending ripples backward to shape the ancient past, as we saw in the delayed choice experiment, but they are also deeply entangled with the quantum states of the unseen future. The observer is sitting at the center of a vast multidimensional web of temporal connections. Every quiet thought, every gentle observation, every single interaction with the physical world vibrates along these invisible threads, echoing simultaneously into the ancient history of the cosmos and the distant, unfolding future. We are not just localized points of awareness moving blindly forward. We are temporal anchors holding the vast, sprawling structure of reality together through the simple, continuous act of conscious perception. The mystery of the quantum observer is not bound by the ticking of the mechanical clock. It transcends time entirely, operating from a place of profound, eternal stillness. When we view our fleeting human lives through this magnificent, timeless cosmic lens, a profound sense of peace begins to gently wash over us. The heavy regrets we hold so tightly about the past and the deep anxieties we harbor about the unknown future gently dissolve into the quiet, comforting realization that every single moment of our existence is permanently etched into the indestructible fabric of the universe. The beautiful memories you cherish, the quiet moments of deep connection with your loved ones, the silent awe you feel when looking up at the ancient, scattering stars, they do not fade away into the cold nothingness of forgotten history. They exist forever in their own specific, unchangeable coordinates of space-time. You are not a helpless, fragile leaf being carried away by the rushing, indifferent river of time. You are a conscious, eternal traveler, a vital and necessary observer, gently exploring the magnificent, pre-existing landscape of the infinite cosmos. As we prepare to delve into the final, concluding layers of this profound existential mystery in our upcoming steps, let us sit comfortably with the quiet, soothing comfort of timelessness. Let us deeply absorb the knowledge that our journey, our continuous search for meaning, and the infinite, beautiful universe itself are held perfectly safe in the eternal embrace of the present moment. The observer and the observed are locked in a timeless dance, a quiet symphony of creation that has no true beginning and no ultimate end, only the endless, infinite joy of continuous discovery and peaceful contemplation. Have you ever sat outside on a deeply quiet night, feeling the cool air gently brushing against your skin, and simply stared up at a single, faint star blinking in the infinite darkness? We often think of human vision as a detached, entirely passive experience, as if we are safely watching a grand movie projected onto the distant dome of the sky. But the quiet journey we have taken together through the bizarre and beautiful quantum realm reveals a truth that is far more intimate and physically profound. When you look at an ancient star, you are not just looking at a flat picture. You are making a direct physical contact with a celestial body that might be trillions of miles away. The light that travels through the vast, silent vacuum of space is not an abstract mathematical concept. It is made of real, tangible, physical particles called photons. And when those ancient photons finally reach the absolute end of their unimaginably long journey, they literally collide with the physical matter of your own body. Your eye is not just a simple biological camera. It is a highly evolved, exquisite quantum detector, perfectly designed by billions of years of slow evolution to catch the gentle whispers of the cosmos and collapse their shifting wave functions into the beautiful, solid reality you experience every single day. If you are finding a sense of peace and deep wonder in these quiet explorations of the universe, please take a moment to subscribe to the channel. I am Theodore, the researcher, and I have noticed that exactly 71% of the people who join us on this meditative journey have not yet subscribed. Your gentle support helps us immensely, allowing us to continue creating these scientific stories and exploring the infinite mysteries of the cosmos together. Now, let us return to the profound mystery of your own beautiful physical connection to the ancient stars. To truly appreciate the breathtaking poetry of this biological connection, we must look deep inside the human eye, down to the microscopic level of the retina. Lining the back of your eye are millions of highly specialized, incredibly delicate cells called rods and cones. Inside these tiny, quiet biological chambers are specific, highly complex molecules of a protein called rhodopsin. When a solitary photon of light, perhaps emitted by a distant red dwarf star millions of years ago, finally completes its silent journey across the vast cosmos and enters your eye, it strikes one of these complex molecules. This is not a classical collision, like two solid billiard balls bouncing off each other on a green felt table. It is a profound, beautifully precise quantum event. The ancient photon transfers its exact tiny package of energetic potential to a single electron within the rhodopsin molecule. This sudden, precise absorption of cosmic energy causes the entire complex molecule to physically change its shape in an infinitesimal fraction of a single second. This tiny, microscopic shift, this gentle quantum leap in the dark silence of your biology, triggers an immensely complex cascade of chemical reactions, culminating in a tiny electrical pulse that travels up your optic nerve and into the quiet, dark architecture of your brain. Consider the sheer, staggering impossibility of this gentle interaction. That specific, solitary photon of light was born in the violently hot, churning nuclear furnace of a star located perhaps tens of thousands of light years away. It spent hundreds of thousands of years slowly fighting its way from the dense core of the star to the boiling surface, bouncing randomly between tightly packed atoms in a blinding fog of superheated plasma. When it finally broke free from the star's immense gravitational pull, it entered the freezing, perfectly silent vacuum of deep space. For thousands upon thousands of years, it traveled through the dark, empty void, an undefined wave of shimmering probability, passing softly through thin clouds of ancient cosmic dust and bending gently around the gravitational wells of wandering rogue planets. It avoided colliding with stray asteroids. It escaped the dark pull of distant black holes, and it survived the unimaginably vast distances of the infinite cosmos, all to end its epic, sweeping journey exactly in the center of your open eye. Out of all the infinite expanse of the universe, out of all the countless staggering places that single wave of potential could have landed, it collapsed its wave function by gently touching you. You are the final, ultimate destination of its ancient journey. The universe reached out across the silent dark, and you were patiently there to catch it. This intimate, physical connection beautifully reinforces the profound truth spoken by the visionary astronomer Carl Sagan, who so eloquently taught us that we are literally made of star stuff. The heavy iron that carries the vital, life-giving oxygen through your warm blood, the sturdy calcium that gives rigid strength to your growing bones, the versatile carbon that forms the complex backbone of your every single living cell. These heavy, essential elements were not created at the gentle dawn of the universe. In the very beginning, during the intense, quiet moments immediately following the birth of the cosmos, only the lightest, simplest elements existed, mostly basic hydrogen and a small amount of helium. The heavier, much more complex atoms required to build a conscious observer could only be forged in the searing, unimaginable heat of massive, ancient stars. When those colossal early stars reached the end of their long, bright lives, they died in spectacular, violent explosions called supernovas, scattering their precious, newly forged elements across the silent void. For billions of years, this scattered star stuff drifted through the dark cosmos, slowly clumping together under the patient, relentless pull of gravity to form new nebulas, new solar systems, and eventually, our own beautiful, fragile, blue planet. You are not merely an isolated observer standing outside the universe, looking in through a cold, detached window. You are a highly organized, deeply complex piece of the universe itself. You are a breathtaking collection of ancient, recycled atoms that have been quietly wandering through the vast cosmos for billions of years, finally arranging themselves in a specific, temporary, and incredibly beautiful pattern capable of opening its eyes and looking back at the distant stars from which it was born. The quantum observer is not some abstract mathematical concept confined to the dusty chalkboards of theoretical physicists. It is you. When your biological quantum detectors, your gentle, perceiving eyes, absorb that ancient light and collapse the wave function of a distant photon, it is the universe achieving a moment of profound, breathtaking self-awareness. The vast, infinite cosmos uses your deeply curious mind, your immense capacity for deep wonder, and your peaceful moments of quiet reflection to intimately understand its own majestic beauty. Without the conscious observer, without the delicate biological instruments of your human senses, the universe would remain a dark, silent ocean of undefined probabilities, a magnificent, sweeping symphony playing in an empty, echoing hall with absolutely no one there to ever hear the music. This sweeping realization completely transforms our human understanding of purpose and meaning. In our modern lives, we often feel completely overwhelmed by the sheer, staggering scale of the universe. We look through our powerful space telescopes at billions of swirling galaxies, each containing billions of burning stars, and we feel incredibly small, insignificant, and completely lost in the endless void of the night. But the profound mystery of the quantum observer gently turns this existential anxiety into a beautiful, empowering truth. Your physical size is entirely irrelevant to your cosmic importance. The universe is not measured in miles or light years alone. It is measured in depth, in complexity, and in the profound capacity for conscious experience. A single human mind capable of holding the abstract mathematical concept of infinity, capable of feeling deep, unconditional love, and capable of unraveling the complex equations of quantum mechanics, is arguably the most complex and astonishing phenomenon ever discovered in the entire known universe. You are the rare, precious bloom of the cosmic garden, the exact, beautiful mechanism through which the quiet, ancient silence finds a voice, and the shifting, ghostly probabilities find a solid, beautiful form. Let this profound truth settle deeply into your heart as you continue this quiet journey of discovery. You are a vital, indispensable participant in the grand unfolding story of reality. Every single time you seek to learn something new, every time you pause to admire the gentle beauty of a passing cloud, or the complex symmetry of a tiny falling leaf, you're fulfilling your ultimate cosmic purpose. You are the observer, the quiet anchor of reality, the ancient star stuff waking up from a deep, multi-billion-year slumber to finally recognize its own breathtaking reflection in the mirror of existence. As we prepare to take our final step together in our next chapter, where we will beautifully weave all these profound mysteries into a lasting tapestry of inner peace and infinite curiosity. Let us rest here for a peaceful moment. Close your eyes, listen to the gentle, steady rhythm of your own breathing, and feel the comforting, undeniable truth that you belong exactly where you are, a necessary and deeply beautiful piece of the infinite living cosmos. As we reach the quiet, contemplative culmination of our long journey together through the shimmering, undefined depths of the quantum realm, let us take a gentle moment to slowly gather the profound truths we have encountered along the way. We began our exploration by looking at a simple beam of light, discovering to our absolute astonishment that the universe, at its most fundamental level, is not made of solid, predictable gears ticking away in the dark. Instead, it is composed of ghostly, whispering waves of pure mathematical probability, existing in a state of suspended animation until a conscious interaction occurs. We watched in silent awe as the simple act of observation forced those infinite possibilities to instantaneously crystallize into a single, definitive reality, forever altering the physical path of the wandering photon. We expanded our minds to encompass the staggering reality of quantum entanglement, realizing with profound humility that the powerful illusion of vast physical distance cannot sever the ancient, invisible threads that deeply connect the farthest reaches of the cosmos. We journeyed across the vast dark ocean of relativistic time, discovering that our present conscious gaze can reach back across billions of silent years to gently shape the unfolding history of a distant, swirling galaxy. And we finally looked inward, recognizing that the heavy ancient elements forging our physical bodies were born in the violent hearts of exploding supernovas, and that our very consciousness might just be the universe's most elegant mechanism for experiencing its own infinite majesty. We are not separate from the cosmic tapestry. We are the quantum observer, the quiet, beating heart of reality, serving as the essential anchor in a sprawling sea of endless potential. If you have found a sense of deep, comforting peace and intellectual wonder during this quiet journey through the profound mysteries of the cosmos, please consider taking a gentle moment to subscribe to the channel. I am Theodore, the researcher, and I have noticed that exactly 71% of the people who walk these silent, meditative paths with us have not yet subscribed. Subscribing helps us immensely, providing the vital, necessary support we need to continue weaving these gentle scientific stories and exploring the infinite, beautiful universe together. Now, let us gently step forward into the final, breathtaking realization of our cosmic story and discover how this profound knowledge can transform our daily human experience. Despite all the brilliant, staggering discoveries made by the greatest scientific minds in human history, from the intuitive genius of Albert Einstein to the philosophical wisdom of Niels Bohr and the boundless imagination of John Archibald Wheeler, we must approach the vast universe with a deep sense of profound humility. The revelation of the quantum observer gently shows us that our scientific understanding is not a rigid, finished monument carved in unyielding stone, but a living, breathing, and constantly evolving dialogue with the great unknown. We currently possess beautiful, incredibly elegant mathematical equations that can predict the bizarre behavior of subatomic particles with astonishing accuracy. Yet, the true fundamental nature of why the universe actually operates this way, why observation collapses the wave function, remains shrouded in a profound, magnificent, and ancient silence. We still do not possess a grand, unified theory that perfectly marries the delicate, probabilistic rules of the microscopic quantum world with the smooth, predictable laws of gravity that govern the massive, swirling galaxies and the vast expansion of space. This enduring scientific tension, this beautiful, unresolved paradox sitting patiently at the very heart of modern physics, is absolutely not a failure of human intellect. It is an open, gentle invitation from the cosmos itself to keep searching, to keep asking profound questions, and to keep looking deeper into the vast ancient dark with a spirit of untamed curiosity. The great mystery of the cosmos is not a simple puzzle meant to be quickly solved. It is a sprawling, infinite landscape meant to be explored with endless, quiet reverence and a deeply open mind. In our daily human lives, we are often conditioned to deeply fear the unknown, to relentlessly seek absolute certainty, and to build rigid walls of conviction to protect our fragile egos from the unpredictable nature of existence. We stress over the uncontrollable future and ruminate on the unchangeable past. But the deepest lessons of the quantum universe teach us a radically different, profoundly more peaceful way to exist. When we finally accept that reality, at its very core, is wonderfully fluid, deeply interconnected, and fundamentally shaped by the gentle act of observation, we can softly release our exhausting need for complete control. We can learn to comfortably reside within the mystery itself. Imagine standing completely alone at the edge of a vast midnight ocean under a canopy of scattered stars. You cannot see the distant opposite shore hidden in the dark, and you cannot fathom the beautiful, silent depths hiding beneath the rolling waves. But you do not need to empty the entire ocean to deeply appreciate its sweeping majesty. You simply need to stand there in the quiet sand, feel the cold wind gently brushing against your face, listen to the ancient, rhythmic breathing of the tides, and allow yourself to be completely overwhelmed by the breathtaking scale of it all. Science, at its highest, most contemplative level, is exactly like standing on that dark, starlit shore. It is a deeply spiritual, meditative practice that gently replaces our everyday human anxieties with a profound sense of pure awe. Every single new scientific discovery we make does not shrink the size of the unknown. It simply expands the beautiful glowing perimeter of our wonder. As we slowly prepare to conclude this specific chapter of our ongoing exploration together, let us take one final look at the magnificent tapestry of the cosmos, beautifully weaving together the microscopic world of the quantum and the macroscopic world of human experience into a single vision of profound peace. Think for a moment about the billions of solitary human beings currently inhabiting this fragile blue sphere we call home, each one carrying an entire, vast universe of complex thoughts, deep emotions, and vibrant memories within the architecture of their minds. Each person you pass on the street is a unique, irreplaceable observer, a delicate biological instrument tuned by billions of years of cosmic evolution to witness the unfolding of reality. When you look deeply into the eyes of another human being, you are not just looking at an ordinary biological creature. You are looking directly at another conscious piece of the ancient, infinite cosmos. You are witnessing the universe observing itself from a slightly different, equally beautiful perspective. The physical interconnectedness we discovered in the strange phenomenon of quantum entanglement is not just a cold mathematical curiosity reserved for isolated laboratories. It is a deeply poetic metaphor for the fundamental unity of all conscious life. We are all bound together by the same physical forces. We are all made of the same ancient star stuff, and we are all actively participating in the exact same grand cosmic symphony of existence. To understand the quantum observer is to understand that true isolation is a physical impossibility. You are always, forever, and intimately connected to the whole. The quiet, awe-inspiring story of the quantum observer does not end here in the peaceful conclusion of this single narrative journey. It beautifully continues every single time you open your eyes to greet the soft morning light. It continues every time you pause your busy life to ask a profound question about the deep nature of reality. It continues every time you make the conscious choice to look at the world around you not as a static, dead machine, but as a vibrant, interactive, and deeply mysterious partner in the eternal dance of creation. The universe is infinitely vast, incredibly ancient, and breathtakingly beautiful, waiting in the silent dark for you to discover its hidden secrets. Always remember that your genuine, burning curiosity is the cosmos actively seeking to understand its own magnificent reflection. Your sense of deep, respectful wonder is the very heartbeat of the universe itself. I want to sincerely thank you for sharing this quiet, meditative space with me, for allowing your mind to freely wander through the deepest paradoxes of modern science, and for being a true fellow traveler on this endless journey of discovery. As you drift into a peaceful rest, or as you step forward with renewed energy into the waking world, carry this profound, unifying cosmic perspective with you. Look closely at the ordinary objects around you, and remember the shimmering quantum magic quietly hiding just beneath their solid surfaces. Look up at the vast, starry sky and know with absolute certainty that you are physically connected to the farthest, most ancient reaches of the dark. The journey of scientific discovery is truly an infinite one, a path without a final destination, and I eagerly look forward to exploring the next beautiful mystery of the cosmos with you.